Okay, so I'm going to check if the streaming is on. As all students will have to join me. All right. So let us take a look at numbers 1, 2, 3, and 4. Here we are adding numbers. And in each case, the numbers all have the same sign. The rule says that whenever that is the case, we should add the values and the answer will take the same sign. So what I'll do, just to not disenfranchise you in any way, is ask you for the answers for the first 4. Okay, the audio is doubled. Is it still doubled? I see the answers going up. Yes, so I see the first one. By the time I write it, hopefully I'll see the next one. The first one is 10. I'm going to write it slant because I don't have the space to write it. So that is 10. Number 1 is 10. We add the values. That's very nice, man. We add the values and the answer will take the same sign as the numbers that we have added. So I've seen a 20 and I've seen a negative 20. So this one is actually negative 20. That one is negative 20. Why 20? Do not forget that when we add numbers with the same sign, the values are added and the answer will have the same sign as the numbers that we have added. So this one has to be a negative 20. And number 3, we're going to add these two and we are going to get what? A negative 40. Why negative? Because when we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. And we are going to go down to this one. And I saw the answer for that one already. 16. There's no difficulty adding all numbers when they are positive. But you cannot retain forever the notion that negative and negative is positive. There is no such thing. That is crap. So there is no such thing as negative and negative is positive. No. When we multiply two negative numbers, the answer is positive. And when we divide and the problem involves two negative numbers, the answer is positive. But when we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So we see students going to number 5. Yeah, number 5 is nice and warm. So I think that you could do number 5 also. For number 5, what do we have? Negative 30. So all of these must be added. 20 plus 10, so that is 30. And of course, all of the numbers that we are adding are negative, so it's a negative 30. Number 12, there's no problem, not number 12, number 6. There's no problem with number 6. You have been adding all numbers that are positive from the day you were born. So, there's no doubt that seeing that this is 45. What about this one? Do not forget to add all of the values and the answer will have the same sign as the numbers that we have added. So that one will be, someone says a negative 20, let me check it. These two will be 5, plus 5 is 10, and plus 10 is 20. So it's 20. All of them have the same sign, so we add the values, and the answer will take the same sign. And finally, what do we have there? Someone says negative 20. No, it's a positive 20. That's nice. So we have, how do we do that? So that it is easy to add. I don't think that number 8 is 20. Oh yes, we have the negative 20 right there. Thank you very much. Which one is negative 5? Surely not number 8. So let's finish that exercise first. So let us take a look at this one. So we have 9 plus 6, that's 15. 15 plus 5, that's 20. Plus 10, that's 30. So I'm very happy that somebody has the answer there already. It's a positive 30 or just 30. How do I write that? Nice. So students, I'm sure that by now, for those who were not here at the beginning, meaning not just the beginning of this class, but also the beginning of the course, we're working with positive and negative numbers. And in the first exercise, generally I don't write from side to side, but I did that in the interest of space. So let us finish with this. Notice that in every single case that we are adding, the numbers have the same sign. And what did we do? We add all of the values, and the answer took the same side as the numbers that we have added. Now I need you to take a look at these 4. Don't write any answer as yet. Take a look at those 4. You can work them out. I see answer coming up on the screen, but I'm not going to acknowledge them because I say that you should not write the answers yet. And I'm not going to go for all 8. I'm going to go for the first 4 first. Okay, so we're going to look at these problems. In the first, what do we notice? We notice that in every single case in this part of the exercise, the numbers are of different sign. Surely, we have a 2 here and a negative 10. And of course, the 2 has to be a positive 2, and this is a negative 10. That causes the 2 numbers to be of different sign. Then we have 5 with negative 7. Again, the numbers are of different signs because the 5 is positive and the 7 is negative. Here again, a negative 4 with a positive 9. No discrepancy. And your favorite, 15 minus 8. So the numbers are of different sign. The numbers are of different signs. When the numbers are of different signs, what do? We subtract the smaller one from the larger, and the answer will take the same sign as the larger. When the numbers have different signs, we find the difference. Let's go. All right, so I'm ready. I've seen quite a bit of correct answers. I've seen the first one to be a negative 8. So why negative 8? Why negative 8? We subtract because they are of different sign, and we get an 8. 10 is the larger one, so the sign of the answer will be negative. The negative number is the larger one, the sign of the answer will be negative. So we go to the next one. 5 minus 7. I see negative 2, and you can go to all of them now. You can go to all of them. Negative 2, and this one will be That's very nice, man. That one will take the sign off which one? What? I'm sure that you're not seeing so well. This one. Did anybody say it's a negative 5? Some say it's a positive 5. Some say it's negative. Justify your answer. It takes the sign of the larger one. The larger one is positive. So the answer has to be positive. And this one, no one can deceive you with this one. I see 13. So I'm sure that the students are not seeing the sign on the screen, but I'm seeing it on my monitor. So you should be seeing that on the monitor. So this one is going to be what? 15 minus 8. And I see your favorite answer coming up. 7. So I am not paying attention to any answer that will go on the screen for numbers 5, 6, 7, and 8. Those are the ones that I'm looking at. 5, 6, 7, and 8. I'm not looking at any answer as yet. I'm giving the students a few seconds. Students, do not forget that this is not a concept class. This one is a tutorial or a problem-solving class. So we have meet.google.com/bjcob. Meet.google. Right. So there you have it. The link that you all need to bear in mind if we should ever have any difficulty, so much so that we have to end the live on TikTok. So I'm not going to go over to it immediately. I'm going to attempt to recover first. So if you see that it's gone, don't try to go over there, because I'm not going to be over there. I have to make sure that I will not be able to recover, and then I will go over there. I'm seeing it on the screen. The person who's saying I'm not seeing any link. I see there going up, Richard James Math Resources, meet.google.com/bjcobhsgvs. See it there? All right, so yes, let's go. I'm delighted to have these done now. Let's go. Now, I'm going to do the problem once, and I'm going to do it again for some other students. All right, so are you the only one not seeing anything? Someone is not seeing anything. Right, I know that I'm continuing on YouTube, Alright, so let's continue. Before I do anything else, I need the answers for numbers 5 to 8. Now students, I'm going to work them out one way, which is the way that I would work them out. And then you can work them out the way that you please. And I'm going to work them out another way. So please take note of the way that I'm going to work, because I'm not going to let them stay on the board too long. Let's go. So this is the way that I would work them out. I will put a negative 10 with a negative 2 plus 7. And what will I get? These two have the same sign, they are added, and the same sign. So these two have the same sign, they are added, and the same sign will remain. And then this is plus 7. Now what happens? They have different signs, so we will subtract, and the answer will take the same sign as the larger. So this one has to be a negative 5. And you have some people beat me to it already. So they have the negative 5 there. Alright, so let's continue. For this one, this is what I would do. Negative 7 minus 8 plus 10. That's what I would do. And what would be my answer? Well, I have a negative 15 here, because I'm going to add the negatives together, and a plus 10. And then the answer will turn out to be a negative 5 again. What about this one? What would I do? I would put the 28 with the 2 and the negative 21 with the negative 19. The 28 with the 2 will give me 30. And the negative 21 with the negative 19 will give me a negative 40. They have different sign now, so I subtract. And the answer will take the same sign as the larger one. Lovely. So let us take a look at number 8. Well, I'm hoping that I wrote it right on the board, because it seems to have so many. A negative 7, a negative 10, a negative 25, a positive 3, and a positive 15. Nonetheless, I will do what? A negative 7 with a negative 25, then a negative 3, negative 7, negative 25, negative 3, then plus 10, plus 15. And what will I get? This will be 25 and these two will be 10. So a negative 35 will go there. Plus 25. 10 plus 15, that's 25. Negative 35 with positive 25 equals a negative 10. So that's a negative 10 also. So let me, yes, the answers are correct. So you are doing quite well for those who are supplying answers. I see 35 students there. And I don't see 35 students answering. But as long as you understand, if you don't understand something, let me know. Of course, some of you who are just joining, you're going to be a little bit slower at it, because this is the final, the end of it, where we have started at the beginning, and we are just solving some problems, just applying what we have learned from a long time ago. All right. Now, I'm going to erase. I'm not going to erase number 8. I'm going to let it stay. But I'm going to go for the rest and show you how some students would solve them. And the answer will be the same nonetheless. Let's go. so this is how some students would do it. They wouldn't bother to put the two negatives together. The students would say negative 10 plus 7. So it will be a negative 10 with a positive 7. So that is going to be a negative number. Because we're adding numbers with different signs, we subtract. And the answer will take the same sign as the larger number. So we'll have a negative 3 there with the negative 10 and the positive 7. Then we'll have a negative 2. And the answer will be negative 5. We add them and the answer will take the same sign as the numbers that we have added. What about this one? Some students would do this. Negative 7 plus 10. And then they will say that is a positive 3. If we're going to put the negative 7 with the positive 10, the answer is going to be positive, taking the same sign as the larger one. And then we will have what? A negative 8. So 3 minus 8. They have different signs. So we subtract again. When we subtract, the result is 5. And the answer will have to take the same sign as the larger one. So the answer will be a negative 5. For this one, what will the students do? 28 minus 21. So that would be a positive 7. And then negative 19 plus 2. What will that be? Negative 19 plus 2. Negative 19 plus 2. And what do we do next? Now the numbers have different signs. Yes, thank you very much. Somebody's right on it. That means if I make a mistake, I can come right here and see my students are supporting me very nicely. All right. So the result for that now will be negative 10 as before. So students, all, I am not saying that my method of choice is better than yours. No, it's not. But I try to do things in a more orthodox way. Because if I do things in an orthodox way, the orthodox students will understand and the unorthodox students will understand. But if I do things in an unorthodox way, only the unorthodox students will understand for the most part. So I'm just making sure. But students, I am not tying you down to a particular method. Let's continue. This is your favorite. Right. Why do you love this set of problems so? I do not know. But I am sure that you find them to be enjoyable. All right? I'm going to give you a few seconds for the first 4. Let's go. A few seconds for the first 4. When I say a few seconds for the first 4, I see numbers flying. All right, so let's go. The first 4, I'm going to do them concurrently. Yes, I'm going to do them concurrently. Now, yes, I'm going to do them concurrently. What do I say now? I'm going to put the 6. The signs are different. I replace them with a negative sign. I'm going to put the negative 3. The signs are the same. I replace that with a positive sign. The signs, I'm going to put back the 9. The signs are the same. I replace that with a positive sign. I'm going to put back the negative 2. The signs are the same. I replace that with a positive sign. I'm going to put the negative 7 again. The signs are the same. I put a positive sign. I'm going to put the negative 6. The signs are different. Oh my, I think that I'm doing too many. I'm going to just put the negative 9 there. Alright, so I'll stop right there for now. As I said, I'm going to do the problems concurrently. That means let them run in terms of time together. I saw somebody mistype because I'm sure that, yes, right, yes, no, right. So what I've noticed there is that somebody mistyped. I'm sure that you mistyped it. I don't think that you really supplied the wrong answer. For this part, number 5, negative 7 plus 5. Somebody put 3 there. I'm sure that you're just not putting a wrong answer there. I think that you made a mistake. Right. So let's go. Right, so let's go now. This is your favorite. 6 minus 4, that's 2. Negative 3 plus 7. Subtract the smaller from the larger, and the answer will take the same sign as the larger. So that's a positive 4. No one needs to explain 9 plus 5 to you. And here, we have a negative 2 plus 5. The signs are different again, so we subtract. After subtracting, we're going to put the same sign as the larger one. And of course, the larger one is positive, so the answer has to be a positive 3. This is beautiful. The next two. Negative 7 plus 5. Negative 7 plus 5. What do we say? Number 5 is 3. Why is somebody still saying number 5 is 3? Unless I'm writing the wrong thing on the board. Why is somebody saying that number 5 is 3? Yes, it is 3. So why didn't you tell me that I put the wrong number here? Right. So it should have been negative 7 plus 10. There you go. Alright, so that's negative 7 plus 10, which of course is 3. And then finally, What's the final one? I'm coming all the way over here to see everybody supplying that answer. Thank you very much. Dark skin boy. Maybe that's not how it is pronounced. Thank you very much. Yes, you wrote the wrong thing. So if I wrote the wrong thing, and just go up there and do that. Yes. Right. So finally, thank you very much. Finally, what's the answer for this one? No answer as yet. I hope that no one is saying that it is 3. We have a negative 6, minus 9, and I see the answers going up right there. So, a negative 15. All right, so of course, if you are just getting in new, or you did not see the work with directed numbers, of course it is going to look hard to you. It's not hard for some of the students who were here from the beginning. Now, we did maybe 2.5 hours of work with directed numbers, 2.5 hours. So if you're just attempting to get it done in 0 seconds, then of course it's going to be hard if the students take 2.5 hours to get it. So it only seems hard though, it just seems hard, it's really not hard. So you can take a look at the instructional manual and take a look at go through the lesson, and you'll find that if you do it in bits and pieces, like how we have done this in 4 rules for addition, because we have 4 rules for addition and subtraction, and we have 2 rules for multiplication and division. Right, so we have gone through quite a bit of concepts with this, and they're all in instructional manuals. So consult your instructional manuals, and I'm sure that you will see how this thing can be very simple. And when you look at the homework exercise and the answers and how they are worked out, then also that will also, be very helpful. So let me just give you an idea. When you, if I can find the other one, yes I can. When you go into your, I'm not going to cause it to remain here. When you go into your regular mathematics class, students, or you go into a regular book, as I like to use that word. When you go into a regular mathematics book, first of all, they are not going to work out the answers like how you should work them out. Right? Yes. They are not going to work out the answers like how you should work them out. They are just going to give you some letter numbers. Letter and numbers, that's all. They are not going to work them out literally. So, I'm just going to give you a look for those students who are coming in new, how we work it out. Now, this is how we work it out, students. I'm going to see if I can peek right over the top and go a little bit back, go to this side. This is how we work it out. We work it out with the hand. So everything is done, let me just show one side of it. Everything is done for you with the hand in the same way that you are required to work it out. Everything is worked out with the hand. So that is whether you're doing the exercise in the book or you're doing the homework exercise. So we do it so that you can follow. We do all the steps, all the necessary steps. That's not directed numbers, but I'm just giving you an indication. So everything is in your instructional manual worked out with the hand. Students, it's not a handwritten book. It's just the answers that we work them out with the hand in exactly the same way that the students should do it in an examination. So all is there. That's how we do it. So you can see. Just follow. You can just get follow. Because as a matter of fact, you don't imagine that I will teach the entire thing over and then the students come in next week and I teach it over and I'm running around on a treadmill. But it's my interest, it is in my best interest that you learn as much as you can from these exercises. Now, I'm going to put another set of exercises on the board so that we can make light work. Finish up the homework exercise for directed numbers. Let's go. We have 3 there, so I don't think that we have 3 more. But maybe one of them is long. So I think that I can write it in all black. For the most part, what we have here is just a single line answer. Again, it should have, this one should not be -5. I'm going to put the right thing. Though, it should have been that, at least. Gee, I don't need 8. Oh, I'm happy that it's just a -4 squared. So here you go. I have another exercise over here. Students, I do not want to see any decimal fraction. No decimal fraction. Okay. That's very nice. So, what it means to me, because it's very encouraging to me that you are doing this in your grade 9 class. Yes. Why is it so encouraging to me? Because it is my intention that by attending these classes online, that it will help you with your schoolwork. And not merely help you with your schoolwork. As you go a bit further, you will see that it will help you with your CXC examination. All right, so I'm going to take them stripe by stripe by stripe. 1, 2, 3, 4, 5, 6, 7, 8. So I think that I'll take the first 8. When you are multiplying two numbers, if it is just two numbers, if it is just two, So, and that applies for multiplication and division. But since we are just multiplying here, let us say multiply. Right, so if you are multiplying and you have two numbers and they have different signs, or we'll say they have unlike signs, the answer is negative. So the first thing that you have to bear in mind is that this answer is going to be negative. Because you are multiplying two numbers with different signs, the answer will be negative. And of course, 3, 5, 15. What do you notice there? Again, you are multiplying two numbers with different signs. It's a negative 5 and a positive 3. So you're multiplying the two numbers of different signs. The answer is going to be negative. And 3, 5, 15. This one is 15. Even in Sunday school, you'll be confirmed. It will be confirmed that 3, 5 is 15. Well, if you're just getting in, you're late. And not just does not mean just now in terms of this class time in this evening, but it also means just in terms of where we have started from September. From the beginning. Not the very beginning of September. Don't worry. Just learn as much as you can as we go along, because the things that we are applying, that we are learning now, I'm going to be applying them a lot, and I'm going to be repeating the rules a lot. So let's continue. These two are like in the exercise. Quite likely in the exercise in your instructional manual, it is not like this. Quite likely. But I'm just doing this for now. And of course, you are multiplying two numbers. They have the same sign. So the answer is going to be positive. So that's a positive 15 also. With or without the sign, it's a positive 15. Now, this one is of a different rule. This one is of a different rule. And of course, we'll see what happens to number 6 and 8. Ready? All right, so let's go. Remember this rule? When we are multiplying many numbers with their signs, we count the number of negative signs. I'm going to invite somebody to discuss a few with me. So I'm going to invite a few to see if you will say anything. So all who have seen, I will invite you. Who wants to take up the offer to come and say something, you may. All right. Now, anybody remember what we say about this one? When we have many numbers with their signs, we count the number of what? What do we count? When we count the number of what? No one is supplying an answer. Alright. We count the number of negative signs. So let us count the number of negative signs. 1, 2, 3. 3 is an odd number. The answer is going to be negative. So if we have an odd number of negative signs, the answer is going to be negative. If we have an odd number of negative signs, the answer is going to be negative. And then we just say 2 5s 10 and 4 10s 40. So that will be a negative 40. I need to hear from the students who have accepted my invitation. All right, let's continue. Now, students, I dare say that the way that students input their values in your calculator, you will get a wrong answer from time to time. For example, if you try to square 6, and this is what you do within your calculator, negative 6. If you do this in your calculator, negative 6 squared. The answer that the calculator will give you is negative 36, which is not correct. And that is why, students, when you're working with directed numbers, you need to internalize the concepts. And not just the concept for directed numbers, but your basic arithmetic. Because believe me, students, you have some really horrible persons who are programming calculators these days. They don't know what they are doing. And also, nobody go up on Google and Samsung. When you go on Google and you Samsung instrument, you just set up yourself a failure. Because the calculator in Google, and somebody asks you a problem, to solve a problem, and they go to Google, you generally wrong. All right. So don't go to Google and find the answer and then come back and argue with people. Right? Right. So that is why you need to know for yourself. Why the calculator will give you the wrong answer? Because you put the problem inside of the calculator the wrong way. Right? If you're going to square a negative 6, you'll have to put everything in brackets and square it. Because this one is the negative of the square of 6. So when you do this, the calculator will square the 6 and put back the sign. But when you do this one, the calculator will multiply negative 6 by negative 6. Okay? So your calculator will multiply negative 6 by negative 6 and will give you the correct answer. So the calculator will do this, which is what you should do. Negative 6 times a negative 6 is equal to a positive 36. This one, student, is the negative of a square, which is always negative. And then this one is the square of a negative, which is always positive. Here again, we have many numbers with their different signs. And what are we required to do? We will what? Subtract the smaller from, sorry, let me go back again. I was just distracted by an answer that I saw on the screen. Sorry about that. All right, so anybody who wishes to make a request to join again, you may. So let me say that I think I was just distracted by some answer that I've seen. So let's go. For this one, what do we say? We are multiplying many numbers with their different signs. And of course, all that we have there is just what? 2 negative signs. And we know that if we have an even number of negative signs, the answer is going to be positive. If we have an even number of negative signs, the answer is going to be positive. So we have just 2 negative signs. That's an even number. The answer is going to be positive. And then we just multiply it out easily. So this is going to be, students, if you have a string of numbers to multiply, don't do it randomly. Look for something that makes it simple, like multiplying the 5 by the 2. So if you multiply the 5 by the 2, you get 10, and then the 3 times 3 is 9. So that's 90. And do not forget that we already settled that the answer is going to be positive. I don't know what went wrong. Why I'm not getting the opportunity you may make the attempt again. I think that we have made the attempt on 2 occasions already. Yes. Now students, as long as I see that, I will invite you in. Now, we may do what we call what? Solve by analogy. When we square the negative 6, we got a positive 36. Therefore, if we solve by analogy, when we square the negative 4, we're going to get a positive 16. Solving a problem by analogy is my favorite method of solving a problem. Because if you see a problem, say you have this one here, and you say the square of negative 6 is a positive 36, then by making use of how this problem was solved, then we can solve the next one in a similar way and get the correct answer. And I see the correct answer on the screen. Thank you very much. Now students, let us take on the next. We're going to go for 9. So we're going to go for 9 students. Let's go. Let's go for 9. So all of these. No what? No decimal fraction. Write vulgar fraction for your answer. It's easier to write vulgar fractions because as long as it does not simplify, you just put one number over the other. Alright, so let's go. I'm going to give you a few seconds. Just get your signs correct. And if the answer does not simplify, you just put one number over the other, and that's all. Let's continue. All right, so let's go. Number 1, learn a few things in mathematics from these exercises. 1, you're going to have a positive divided by a negative. The answer is going to be negative. And it doesn't matter when you're writing the answer. So it is 3 divided by 8, so it's going to be 3 over 8, and that is your answer. Now students, when you are dividing and you have two numbers and they have different signs. For example, you can write an answer like this. -3 over 4. The negative of 3, let me write it. The negative of 3 over 4. And of course, you can write 3 over -4. All of those answers are correct. Let me cause this look more like a -3. Yes. All of those answers are correct. All of them are equal. However, when you're writing an answer, you should not write it like this. It is not wrong, but you should not write it like that. And that's why I'm not putting an extra because it is not wrong, it is correct. But do not write an answer with a negative denominator. Put the negative in the numerator or put it for the entire fraction. Never you write your answer with a negative denominator. And as you go along and you get more advanced, you know that you should not write what? An irrational. You should not write an irrational denominator, and you should not write a complex or imaginary denominator. There are certain things that you do not do in mathematics, especially the denominator. The denominator should not be irrational, it should not be negative, and it should not be complex, and it should not be entirely imaginary. So let's continue. Somebody gave me this answer already. -1. Signs are different, you get your -1. What about this one? The signs are the same. I don't think that this is what I have there, but let us do it the way that we have it on the board. So what do we have for that one? Negative divided by negative is positive. So it's positive and it does not simplify. We have 8 over 3. This one is your favorite. 3 over 8. And what about this one? The signs are different. The answer is going to be negative. Negative, it does not simplify. 7 over 2. And this is your favorite. 1 divided by -1. Whoa. Were you saying 3 over 2? Because I do not think that you were saying 31 over 2. All right, so let's continue. We have 1 divided by -1. What will that be? You cannot simplify 1 over 1, -1 over 1? Come on, you must know what 1 divided by 1 is. You cannot write -1 over 1 for an answer. The teacher will not look at it, and the examiner will not look at it either. This one is what? -1. It is not that your answer is wrong. It is not wrong, student, but it's not in an acceptable form. So when you write -1 over 1 is correct, or you write 1 over -1, it's correct. But that form would not be acceptable because every human being expects you to understand or to know what 1 divided by 1 will give you as an answer. What do we say here? You are dividing a negative by a negative, so the result is going to be positive. It's going to be positive, and it's going to be a 6 over 4, which simplifies to 3 over 2. Oh, that's the one you're talking about. Then you are so far ahead of me with the 3 over 2. Yes. I hope that you would not write 6 over 4 as an answer to be presented to an examiner. Because quite likely, although it is not wrong, you'll take marks. Yes, it is -1 for this one. Number 8 is -1. So that you are ahead of me, Mumsy. So this is -1. So we are dividing, the numbers have different signs, the answer will be negative. And of course, 4 divided by 4 is 1. What about this one? I'm going to look, I'm seeing the answer already. I think that it's great. By the time I get to the computer, students have the answers already. Not that. This. Now students, 2 takes longer than 5. Oh yes, -2. Of course, the answer is going to be negative. A positive divided by a negative, the result is going to be negative. And 10 divided by 5 is 2. The answer is a -2. The first thing that we decide on right there, that's very nice, man. How I got number 7? How I got number 7? I think that you could do it on your own, -6 divided by -4. You know from 150 years ago that if you are dividing, the dividend is the numerator and the divisor is the denominator. You know that, so it's going to be 6 over 4. So when you are dividing like that, it is the same as 6 over 4. And of course, that fraction is not in its simplest form. You can simplify that fraction. 2 into 6 is 3, and 2 into 4 is 2. So your answer is 3 over 2. Well, let's see if it is 8. So let us go back to number 10. Remember now, when we have a multiplication and division problem involving several numbers with their signs, we count the number of negative signs. So for now we have 2 negative signs, so the answer is going to be positive. The answer is going to be positive, which is going to be what? 12 times 4 over 6. 6 into 6 is 1, and 6 into 12 is 2. 2 4s, 8. Somebody said 8, and the person is correct. What about number 11? Number 11, how many negative signs do we have there? We have 1, 2, 3 negative signs. We have an odd number of negative signs, so the answer is going to be negative. Yes, we have an odd number of negative signs, the answer is going to be negative. Students, don't bother to write this down and simplify it, because it's so blatant in front of your face. You can see the 7 will cancel the 7, and the 6 will cancel the 6, and all is left is 2. Students, I am not taking the -2 from here and put it there. That's not what I've done. Because what I've realized is that we have 1, 2, 3 negative signs. 3 is an odd number. This answer is going to be negative. We count the number of negative signs. If the number is odd, then the answer is going to be negative. And of course, after that, the 7 cancels the 7 and the 6 cancels the 6. The 2 is left, and that's all there is to it. And somebody might want to try a similar trick with number 12. What do you say about number 12? 11 is negative 2 for sure. Thank you for making your correction. Let's continue. All right, so for the last one now, students, do not forget 2 takes longer than 5. It is better to take 2 extra minutes to look at a problem than 5 extra minutes to solve it. Let me go again. That's not what I should have said. Let me repeat it. It is better to take 5 extra seconds to look at a problem than 2 extra minutes to solve it. So what do we say here? Students, you are sure that because we have a single negative sign there, the answer is going to be negative. So you know that the answer is going to be negative already. Hopefully you can see this. 4 6 is 24. 8 3 is 24. So this will cancel with this and the answer will be a negative 3. You do not have to and start to chop numbers like that. You can see that 4 6 is 24. 8 3 is 24. So the 4 times 6 will cancel with it. 8 times 3 and all will be left is this 3. And that's all there is to it. Okay. Now students, what we did not do on Thursday, I'm going to do it now. What I did not do on Thursday, I'm going to do it now. It's a lot of work. Let's go. Because coming Thursday, I will not do it again. Because it's problem solving. You would have done the yes. That one is, no, that one is hilarious. I was not paying attention. All right, hold on a few. When the live ended on Thursday, the students were given this problem to solve. And of course, you solved it. Quite a few of you solved it and got it right. But let us do it again now. 243 to the power of 5 times 27 to the power of 3 over 81 to the power of 8. That's the one that you did on Thursday. And I am sure that, you know, the students, I think that you did extremely well answering that problem correctly. Yes, you did quite well answering that problem correctly. Now, students, there's a rule that says whenever we have a problem involving numbers with the same base, we convert them to the same base before attempting to solve the problem. Right. That's excellent, man. Right. So let's go. Now, you also have your table. Students, when you miss class, you are late for class, whether late in time for a particular class or late in the school year, like we have started already, of course you're going to be at a disadvantage. But what I've tried to do over the years is to cause you not to be so much at a disadvantage by writing the instructional manual. Because when I write the instructional manual, I'm trying to see behind it. When I write the instructional manual, you are able to follow the manual and catch up on the lesson, because it's all there in the manual. Whether you think you can or you think you can't, you are correct. If you think that you are going to do the greatest in mathematics, yes, you can. If you think that you can move from a 6 to a 2, I'm sure that you can. But this is the most dangerous thing. If you tell yourself that you can't, well, if you tell me, it's one thing if you tell me, but if you tell yourself that you can't, it's going to be next to impossible for me to help you. So if you are willing to get assistance, fine. But if you give up, then tell me, what can I do to someone who has given up? Once you imagine that you can get it done, 100% I'll ensure that you get it done. You have some students who are inside here who you are going to pass the examination and you are going to even surprise yourself. A lot of you. Because I have what it takes to pass the examination and I know what you need. And I have it right here with me. So let's go. What do we say about this problem? From what we have done on Thursday, you have the table in your instructional manual. And in that table, you have 243, 27, and 81 to be all powers of 3. So much so that you solve the problem and you supply the correct answer. So 243 is 3 to the power of 5. That's 243. Or if you wish, we can write it back. 243, put it in brackets, to the power of 5 times 27 to the power of 3 over 81 to the power of 8. So what do we do? In our table, we have it in the table that what? 243 is what? 243 is 3 to the power of 5. What about 27? 27 is 3 to the power of 3. And what about 81? 81 is 3 to the power of 4. And of course, we did our laws of indices that when we have a number with a power raised to another index, we multiply the exponents. So we're going to multiply. So we're going to have here 3 and 5 times 5, 25. We're going to have 3 and 3 times 3, that's 9. Then we have 3 again and 4 eighths, 32. When we multiply numbers that have the same base, we add the indices. When we multiply numbers with the same base, we add the indices. Students, I'm seeing the light flickering, so I hope that the current does not go, but we see the light flickering just now. 3 to the power of 34 to be divided by 3 to the power of 32. And that will be your answer. When we divide, we subtract the index of the divisor from the index of the dividend. So we have 3 to the power of 34 minus 32, which is equal to 2. And then, of course, 3 to the power of 2. If you want to leave it like that, it's fine. But 3 to the power of 2 is 9. And you got that for your answer. And yes, I saw that. And I did not only see that, but I saw students arriving at 9 for your answer. You were here at the beginning. You better get serious now. Because when I go on the board to do something, I'm not going to do it over because you were not paying attention. I'm going to move merrily to the next one. All right. Now, this is what you should do after. So let's go. We have 9 problems. Number 1, 7 to the power of 4 times 7 to the power of 2 times 7. Number 2, 8 to the power of 8 over 8 to the power of 5. Four squared raised to the power of 4. 4. P to the power of 4, Q squared, R. R all raised to the power of 5. I think it's number 5. Find the values of for number 5. and number 6. Okay. All right, so someone asked me to work out this problem again. The person who asked me to solve this problem again, answer very quickly before I erase it from the board. No, first of all, did you do indices with me on Thursday? Let's go. Okay, you did not do. Then you would not follow this then. Do you have the instructional manual? Do you have the instructional manual? All right. So you know what that means? That means you are in a particular situation and the tools that you need to get you out, you don't have them. Because this problem, everything was discussed about this problem on Thursday. And if you were not here on Thursday, it would not be so bad if you have the instructional manual. Now you're required to solve that problem. This time I'm not going to put this in. I'm just going to do it once. You're required to solve that problem. Now, in order to solve this problem, it is suggested that since the numbers have different bases, you should bring them to the same base. If you are not here Thursday, and you do not have instructional manuals, then quite likely you will not see that 243, 27, and 81 are powers of 3. Now, as a matter of fact, 243 is 3 raised to the power of 5. That's 243. That's what 243 is. In addition to that, 243, which we have here, is also raised to the power of 5. Then 27. 27 is also a power of 3. 27 is 3 to the power of 3. And of course, 27 is also raised to the power of 3. So 3 to the power of 3 is 27. And then 27 is raised to the power of 3. Down here, 81 is what? 3 to the power of 4. And of course, 81 is raised to the power of 8. What do I mean when I say 81 is 3 to the power of 4? If you take 3, multiply by 3, multiply by 3, 4 occurrences of 3, 1, 2, 3, 4, multiply them together, you are going to get 81. So that's what we mean when we say that 81 is 3 to the power of 4. 27, if you multiply 3 by 3, and then multiply by 3 again, you're going to get 27. Because there are 3 of them, 1, 2, 3, then 27 is 3 to the power of 3. And of course, you imagine that for 243, you'll have to multiply 5 occurrences of 3. Now the rule says that whenever we have a number with a power that is raised to another power, we multiply the indices. So 5 times 5 is 25, and then you go again, the power, you multiply the powers. 3 times 3, that's 9. Then you multiply the powers again. 4 times 8, that's 32. 3 to the power of 32. Then there's another rule, different from that, that says when we multiply numbers with the same base, we add the indices. So you multiply these numbers with the same base, you add the indices. So that's going to be what? 3, add these, you're going to get 34. When you are multiplying numbers with the same base, you add the indices. When you are dividing numbers and they have the same base, you subtract the index of the divisor from the index of the dividend. When you subtract, you'll get 2. And 3 to the power of 2 is 9. Why? Because 9 is merely 3 times 3. 2 occurrences of 3 will multiply to give 9. Of course, 3 to the power of 2 is equal to 9. Alright, so, not this side, this side. Let's continue. Nice. Now, for those who are not around, we are going to be applying the rules that we learn. And of course, this will not take the place of your class, but I am sure that you will find it to be quite useful, because we are going to be applying the concepts nonetheless, and I'm going to mention them. So the first one, what is the answer for that one? I'd like to know. I'm going to write it over so that we can write the answer beside it more conveniently. Whenever we multiply numbers with the same base, we add the indices. Whenever we multiply numbers with the same base, we add the indices. So that's going to be 7 to the power of 7. How comes when we see 4 plus 2 equals 6? Because when the number is not accompanied by an index, the value of the index is equal to 1. Okay. Alright, so you cannot see number 2. That's very good and that's very bad. Alright, so I hope that you understand number 1 so far. Number 2 is a to the power of 8 divided by 8 to the power of 5. So that's what number 2 is. A to the power of 8 divided by a to the power of 5. And I see answers coming up. A to the power of 3. Whenever we divide numbers with the same base, we subtract the index of the divisor from the index of the dividend. 8, a to the power of 3. A to the power of 3 is right. What do we say about that one? When we have a number with a power that is raised to another power, or we can say it in 3 ways. Yes, somebody is saying 4 to the power of 8, that's nice. When we have a number with an index that is raised to another power, we multiply the exponents. 2 4 is 8. So that one will be 4 to the power of 8. So what do we say about number 4? G. Number 4, I will see. The only reason for you getting number 1 wrong is because you did not add the 1 that is for this one. So when you add the 4 plus the 2 and you get the 6, this one, when we do not see an index, the value of the index is 1. So it should be 4 plus 2 plus 1. So let's continue. Right here, what do we say about this one? I'm going to take off this problem. No. What do we say about that one? I think that I should put the other problems on the board before bothering about it. Alright, so I'm going to put the other problems on the board. Number 7. I'm going to put number 9 and leave it up somewhere. Alright, let's continue. Let's continue. For this one, what's the answer? I'm going to write it in blue over here. p to the power of 4, q to the power of 2, r, all raised to the power of 5. Now students, there is no way we can add those indices. We cannot add those indices we cannot add those, no. Because you do not know the rule. Why? Yes. Yeah, understand that. And for you to understand the rule, you have to be following these things seriously with the instructional class and also in your instructional manual. Now for this, what do we say for this? We cannot add the indices here. We cannot add the indices there because, let me get the answer from you. Why is it that we cannot add these indices? Okay. All right, so let's continue. All right, for sure. We know that because it's because of the power, those numbers with their powers raised to another power, you multiply the indices. So because you know that you need to multiply the indices, then you're going to have p to the power of 20, q to the power of 10, and then r to the power of 5. Because the index of the r is equal to 1. We cannot put these together, and no one answered that question. Yes, see, they are not the same. Yes, we cannot add the indices there because they do not have the same base. So the bases are not the same. So the answer is p to the power of 20, q to the power of 10, and of course there's no index there. The index is 1. 5 times 1 is equal to 5. Nice. So I'm going to move nicely to number 5. Find the values of 10 to the negative 2. We have a negative index. We do the reciprocal and change the sign of the index to positive. So when the index is negative, we may do a reciprocal and change the sign of the index to positive. All right. I'll surely show you, speak to you concerning how you arrive at the instructional manual. No problem. All right, I'll do that in a few. You may leave it like that, or you know that is 1 over 100. This one, you know what you need to do. Do the reciprocal and change the sign of the index to positive. And what will that be? 1 over 64. What about this one? Again, we do the reciprocal and change the sign of the index to positive. And finally, you do the reciprocal and change the sign of the index to positive, and that is going to be equal to 1 over 64 again. So notice what we are doing here. When the index is negative, we do the reciprocal and change the sign of the index to positive. Of course, some of those powers are inside of your instructional manual in the table that you have there. Of course, 4 to the power of 3 is not there, but it is not far-fetched, because 4 to the power of 3 is equal to 4 times 4 times 4. And what will that be? 4 times 4 is 16. 16 times 4 is 64. So that one you'll be able to tell also. That's nice. Of course, I'm going to erase the illustrations in a minute. Look how close number 8 is to it. Number 8 is too close to number 7 for comfort. Alright. So let us continue. Number 6 says express as powers of 2. Students, what do you mean by express as powers of 2? The answer must be 2 raised to some power. So the answer will be what? 2 raised to some power. Now that we have what? 4 raised to the power of 5. When you are finished, your answer should be what? 2 raised to the power of something. That's what the answer should look like. For 8, your answer should look like what? 2 raised to the power of something. And for this one, your final answer should look like 2 raised to the power of something. That's what we mean when we say express as powers of 2. Now I'm going to do the first one. The 4. 4 will be changed to 2 to the power of 2. So we'll change 4 to 2 to the power of 2. And then that is raised to the power of 5. So 4 is 2 to the power of 2. And then that is raised to the power of 5. And what do we say? 2 5s, 10. What about 8? 8 will be what? 2 raised to the power of something, then raised to the power of 7. Let's go, students. What do we say for that one? 2 to the power of 3. That's nice. 2 to the power of 3 raised to the power of 7. 3 sevens, 21. And 16 is going to be what? 2 to the power of what? Raised to the power of 3. Two to the power of 4, then raised to the power of 3, and we finish up by saying 2 to the power of 12. Nice. Now, students all, we have already exceeded the time allotted for the class. But what I'm asking your permission for is just to continue, because remember now that on Thursday, the class was interrupted and we were unable to continue. So I'm just asking your permission to continue. Right, someone is saying yes already, thank you very much. But I make an attempt to ensure that we do not go over 8:30. And concerning the instructional manuals, they are all the way over there. Hopefully I can find some nicely put together over there, because we converted the office into a book factory. So I'll gather those for you nonetheless in a few minutes. All right, so we'll take these out. And do not forget, we have done all of those already. So I'm going to erase all the way down to number 5. Find the balance up. I'm not going to erase anymore. So I'm going to take that number 7 and put it over here. 243 to the 1/5 multiplied by 64 to the power of a half, then times 1,000,000 to the power of 1/3. I hope it will not be so wide on the board when we make the next step. All classes begin at 6 p.m. Alright, so let's continue. What do we say now? Let us we have a rule that says that whenever we have a problem involving numbers with different bases, we bring them to the same base before attempting to solve the problem. It surely can be applied here, but it is not convenient to do so. Additionally, we have other information that we can make use of. For example, it is in your table that 243, and we have mentioned it quite a few times this evening, that 243 is actually what? 3 raised to the power of 5. So that's 243 is 3 to the power of 5, and that is raised to the power of 1/5. What else do we know? Let me see if you're going to write 64 in index form, let me see somebody write 64 in index form. Let's go. I want to see that. Oh, the Thursday class is a bad class for you. Okay. let me see you write something about 64, giving me in index form. 2 to the power of 6. That's the only one you can write for 64? I'm going to use 2 to the power of 6. But is there any other way that you can write 64? Taking it straight from the table that is in your instructional manual, that's what we have. 4 to the power of 3, lovely. And the most obvious one, 8 to the power of 2. 8 to the power of 2, you missed that one. And then this one now is what? 1 million will be written in index form as 100, not 100. 1 million written in index form will be what? Let's go. 10 to the power of 6. Of course it's 10 to the power of 6. We used to do this in primary school. Count the number of zeros. 1, 2, 3, 4, 5, 6. And that is how we know that it is 10 to the power of 6. Or to the power of 1/3. Then what do we do? Apart from nothing. We must know this from the beginning. We multiply the indices. We're going to multiply the indices. So we multiply 5 by 1 over 5. Or we're going to do it like this for convenience. Times 1 over 5. And of course, 5 as a fraction is 5 over 1. So when we cancel, we'll get 1. So we'll have what? 3 to the power of 1 will go there. What about 6 times a half? I'm not going to simplify that one for you. 6 times a half is a half of 6. What's a half of 6? Yes, 6 times a half is a half of 6. We have that one there. So it's going to be 2 to the power of 3. And 10 to the power of 6 times 1/3. 6 times 1/3. Exacto. So that's it. And what do we know? That we'll have what? 3 and 2 to the power of 3. You have that in your table, or you can multiply it. 2 times 2, 4 times 2, 8. And then of course, because of the power of 2, you know it has 2 zeros. And what is your answer? 24 followed by 2 zeros, 2,400. Nice. Now students, for the other one, I'm just looking at the time. Yes, for the other one, this one, I am doing this with the consideration that we have not solved linear equations as yet. So that's what I'm doing. Right. Alright, so we have not done linear equations as yet. So a little bit of this might be somewhat strange, but let us make an attempt nonetheless. Alright, so here we have 3 to the power of x plus 1 is equal to 9 to the power of x. We're going to bring them to the same base. Bring them to the same base. So we have 3 to the power of x plus 1 is equal to 3 to the power of 2 raised to the power of x. Because 9 is 3 to the power of 2. So what do you notice? You notice that we have what? 3 to the power of x plus 1 is equal to 3 to the power of 2x. So now you may arrive at the conclusion that if you have 3 raised to this power and the same 3 is raised to this power, and then the results are the same, the powers must be the same. So we have x plus 1 is equal to 2x. So let me give you an idea how we arrive at that conclusion. Let me show you how we arrive at that conclusion. Let's say you have 3 to the power of 6, and that is equal to 3 to some power inside of this box. What power would you put inside of the box? Because if they are equal, the bases are equal, the two sides are equal, okay, what I'll do, I'll move the problem somewhere else. I try to dampen the light so it looks, but it will not work. I'm going to put it in black. Look over here for that one now, students. 3 to the power of x plus 1 is equal to 9 to the power of x. And we said that 3 to the power of x plus 1 is equal to 9 is 3 to the power of 2. So 9 is 3 to the power of 2. That's what 9 is, but 9 is raised to the power of x. So what are we doing here? We are converting the numbers that we have there to the same base. So we are converting those numbers to the same base. And of course, we know some basic stuff, especially from the exercises so far, that 3 to the power of x plus 1 is equal to 3 to the power of, we multiply the indices. 2 times x is 2x. Right? 2 times x is 2x. And then what do we do next? We say that, like what we have over here, if we have 3 raised to something, and then it is equal to 3 raised to something else, then of course the two powers must be the same. That's only logical. So, since the two powers are the same, we have x plus 1 is equal to 2x. X plus 1 is equal to 2x. Let me write that again. X plus 1 is equal to 2x. X plus 1 is equal to 2x. And we're going to solve that equation to find the value of x. I'm going to solve that problem and find the value of x. So what do we say? Apart from nothing. We will subtract x from both sides. Subtract x there, subtract x there. What do we have? The x minus x that has a cancelling effect on that, and we just have 1 is equal to, and then 2x minus x is x. So in the end, x is equal to 1 for that one. We are saying that x is equal to 1. Of course, 9 to the power of 1 is 9. And if we have 1 here for x, 1 plus 1 will be 2. And 3 to the power of 2 will be 9 also. So that one is also correct. Someone is asking, why is it I do not make a Google Classroom? I've given it thought already. So I'll do that in a minute. Not in a minute, but with time. Now, let's take a look at this one. Now, I'm going to ask 2 questions. The first one is, what is the base that we should use for both of these? We are going to bring them to the same base. What is the base that we should use for both of those? Yeah, I understand that. That's nice, man. All right. So, the common base is 2 is correct, right? The common base is 2. All right. And then, what do I write for 32? So we have 2 to the 2p minus 1 is equal to 32. And of course, 32 will be written with 2 as the base. And of course, somebody says 2 to the power of 5. Excellent. So that's 2 to the power of 5. Now students, if the 2 sides are equal, the 2 bases are equal, then the 2 powers must be equal. That's just basic common sense. So 2p minus 1 is equal to 5. Now, I am not going to use orthodox. I'm not going to be using orthodox transposition concepts to solve that equation. I'm going to use just pure common sense, and I'm sure that everyone will get it. All right, look at this now. There's a number from which we subtract 1, and the result is 5. There's a number from which we subtract 1, and the result is 5. What is that number? I've said it twice, I'm going to say it more times. There's a number, and when we subtract 1 from that number, the result is 5. What is that number? 6. Right. What it means is that, then 2p is equal to 6. All right. So here's the final part of it. 2 times a number is equal to 6. What is that number? 2 times a number is equal to 6. What is that number? So p is equal to 3. Students, common sense is greater than mathematics. So, as long as you don't have to worry about mathematical concepts. Of course, you will learn them and you'll find them. Some of them will be challenging, some of them will be easy. But if you are prepared to use your common sense, then you are sure that you will make something great out of mathematics. Now, students, as I said before, I converted the entire classroom into a book factory. So, because I'm online, you're not seeing anything, you're just seeing the screen, you're seeing the board. Right? But I have stuff all over. Nonetheless, I will return in a jiffy with some resources. Alright, so we have the instructional manuals, now we have the rest of them. Right here. Right. Some individuals do not know that, I am sure when you see me standing like this now, then you know we have quite a few books for the entire course. Right, so, yes, inside, in this hand here, I have the 7 instructional manuals, and here we have the other resources. So, the 7 instructional manuals. Of course, this is the last one. We have vectors, matrices, and transformation. We're not using this one immediately. The Tuesday class will use this before January, because you're going to go off from January for the most of you who are doing the pre-CIT exam. So we have vectors, matrices, and transformation. We have your favorite, algebra. And yes, this one is for $2,000. Jamaican, you know Jamaican currency, not so heavy. Yes, so this one is functions part 1 that the Tuesday class is using at the moment. So we have functions part 2 because we have 7 instructional manuals. Computations part 1. Computations part 2 and geometry. And everybody's favorite, trigonometry. Yes, we have an entire manual for trigonometry. Now, if I should want to run through the prices for you, let me do that. This one is for $2,500. Of course, it's one of the larger of the manuals. This one, algebra, is for $2,000. 1,500. 2,500. No more for 2,500. This one is for 1,500. This one is for 2,000. And finally, this one is for 1,500, your trigonometry. Of course, we have the tutorials over here. Tutorials 1 and 2. We are using tutorial 1 now, students, although we did not use it this evening. This is the real book for Sunday class at the moment, because Sunday is tutorial. Notice what I've done today so far, although I've not gone into the tutorial book. All that I've done is solve problems. Sunday is a problem solving class. So we have the 2 tutorial books here, tutorial 1 and tutorial 2, and each one of those with their question books, because we also have question books for them. Here they are. When you put your tutorial set, each set is for $3,000. Where do I put them? All right. And of course, as you approach the examination, final examination preparation resource book, this one is your paper 2 solutions. Right. Paper 2 solution, because it's a solution book, it is written entirely with the hand. And if there are diagrams, hopefully when I turn the page I'll see diagrams. Not yet. So if you have diagrams, they are drawn with the hand. Everything is done with the hand for you. Your graphs, your tables, and everything is done with the hand. All right. So the question is, where am I and where can I buy them? Yes, I'll answer those in a minute. And of course, do not forget this one. You use this book and use it the right way, you will never fail mathematics. I'm not saying you're going to get a distinction, because this one will not by itself enable you to get a distinction, but surely it will prevent you from failing the exam. Now, where am I? I'm in Montego Bay. So if you're in Jamaica, it's easy, right? So the students who are in Jamaica, you just let me know where you're at. What my customers out of the parish do, they ask me for my account details. I send them the account details. And those outside of parish, what they'll do is just make the transfer to my account, notify me, I run over to the Knutsford Express office, and I send it to students. So the places in Jamaica that most people purchase books from, Kingston and St. Andrew, St. Catherine, so the St. Catherine people use Angels. And then we have, of course, St. Anne. St. Anne people, they used to use Ochi, now they use Draxall. You have Manchester, they use Mandeville. St. Elizabeth, they have 2. They have Gutters and they have Luana. And of course, Westmoreland, you have Savannah Lamar, or we say Sav Lamar, or we say Sav. So it depends on where you're at. And if you don't want to use Knutsford, then you will have to tell me the courier service that you want to use. But I'm telling you the most popular ones. Kingston and St. Andrew, Westmoreland, Fasav, St. Elizabeth, Luana and Gutters, Manchester, Mandeville, St. Catherine, Angels, and St. Anne, Draxall. The only class that I will have time for this school year is the ones that I'm doing online like this. So I'm here from 6 to 8. It should have been to 8. Should have been from 6 to 8. And it is Sunday, Monday, Tuesday, and Thursday. We have 4 classes. Sunday, Monday, Tuesday, and Thursday. So, if you have further questions, I am sure that you have other ways of contacting me. I'll pay attention to my social media. Well, I'm paying more attention to TikTok and also Facebook. I have a Facebook account, Richard James, just Richard James. And you'll still see the logo, although it's just Richard James. And of course, I have Richard James Mathematics Resources. You'll see that. I don't pay as much attention to Instagram. So it will be TikTok, YouTube, and Facebook that I pay a lot of attention to. I will see it more naturally on YouTube. Well, I don't think that there's any favorite there. So for those 3, Facebook, YouTube, and TikTok, then you may message me if you need any detail. A lot of you, well, some of the students would just join because it's available on, so they don't have any means of contacting me. Make use of those social media, and of course, I'll get to you in short order. Any question about the resources? Any other question about the resources? Any other question about how you might get them? Ask that. You may ask that now, so I expect to see questions coming up in the live chat. Right, so I'm looking if there's any more question. Yes, sir. No, everybody knows that is Tuesday. Oh, I thought you said Tuesday isn't for us. Oh, it's for everyone, believe me, Tuesday is for everyone. But if you are not doing the examination in January, you do not have to go on Tuesday class. You have to process the information properly when I give them to you, because I give out a lot of information. So the Tuesday class is mainly for students who are doing the examination in January. Everyone may join, everyone may learn, but I will be leaning the class towards those students who are doing examination in January. So if you're not doing the examination in January, you may still join, but I may just zip through. Okay, good. Okay. Because make sure that you keep that link close by your side. BJCOBHSGVS. GVS, so it is. Meet that Google. meet.google.com/BJCOBHSGVS. So meet.google.com/BJCOBHSGVS. So there's the one that if you have any difficulty. So students, classes are, the day for classes are Monday, Tuesday, let me go back again. The days of classes are Sunday, Monday, Tuesday, and Thursday, beginning at 6 p.m. And all classes are for everyone. But the Tuesday class, you do not have to attend it if you are not doing the exam in January. But you know that I will suggest that you still pay attention to it because you must learn something. All right, so that's that. The Sunday class is a tutorial class. It's a problem-solving class. We should really be using the tutorial one. But if we missed out on something during the week, I will use the tutorial class to make up for it, like how we were supposed to solve those problems and didn't get the opportunity to solve them on Sunday. So, on Thursday. So we put them to today because it's a problem-solving class nonetheless. And of course, students, you know okay. All right, students, so you know that we are close to the end of it. And of course, I'm not just going to leave like that. I'm going to say thank you all for joining the class. Thank you for sharing everything with your friends. Thank you for liking, thank you for gifts, thank you for whatever you do. Do not forget that this is it's not a money-making class. It's a free class. However, students or parents or enthusiasts who you want to make a donation, of course you may. I'm not going to turn on a donation. There are so many things that I need to do for the students of this country and also for the rest of the Caribbean. And of course, anything will help. But it's not that we are doing it with the pretext that you are going to make a donation. That's not the whole idea behind it. But if you will, believe me, I am very grateful for it. So I'm not going to say, oh no. If you're going to make a donation for it, but just to let you know that that's not my real intention for having the class. So thank you for telling others. Thank you for sharing. Thank you for following. Thank you for participating. And thank you again, because when I made a mistake, you have students who are ready to point it out. Point out my mistakes, students. Point out the mistakes. I should have minus 10 and something like that, and I end up putting 5. That's right. I'm sorry if I'm human. I'm sorry if I make mistakes. Right? Right. So I'm not going to be egotistical about that one. So thank you all for every single thing. And when you see the hands go up, then you know that the class is at an end. So for now, it is what? It's not so long like from Thursday to Sunday, no, it's tomorrow. For now, it is what? Goodbye and have a good night's rest until we see each other again at 6 p.m. tomorrow, Monday evening.